Hello and welcome. My name is Tanya Radeva and I'm Program Manager at Windows Debuggers team.
Hi, my name is Joe Ballantyne, and today Tanya and I are going to be talking about new features in Windows 8 kernel debugging. I'm going to be talking about new debug transports that we're supporting in Windows 8, and Tanya will be talking about new certification requirements that we have for Windows 8. The first thing that we'll cover are modern debug transports that we've added to Windows 8. The next thing that we'll talk about is why it's so important for Windows machines to be debuggable. Finally, we'll talk about Windows certification requirements that have been added for Windows 8. When you leave, we want you to know what you need to do to leverage the new debug transports that are shipping in Windows 8, how to turn them on, how to use them with the Windows debuggers. We also want you to know exactly what you need to do to design machines that are debuggable for Windows 8 so that they can be certified. Windows has shipped with kernel debug transports for many years. One of the things that we noticed several years ago is that the existing transports that we've used, like Serial and 1394, have been starting to disappear from machines. Most modern machines don't come with Serial at all, and 1394 is being phased out over time. USB 2 hardware is still available in most modern machines, but it is also starting to disappear because it's being replaced with USB 3. Furthermore, it's hard to set up debugging on USB 2, and it requires that you purchase a relatively expensive external dongle in order to make it work. Because of these problems, we've decided to add support for new transports that will be available in modern machines. These transports are USB 3 XHCI debugging and network debugging support. The goals that we had for these transports was to be sure that they would be easy to set up, that you wouldn't require any special cables to use them, that they would be faster than both Serial and USB 2 debugging, and that they would be available in modern form factor machines. Network kernel debugging allows you to debug target machines or test machines directly over the network. You simply use the debugger on your dev machine and talk directly over the network to the Windows machine that you want to debug. Network debugging supports machines that have a single NIC. You can turn on debugging on that machine and still use Windows networking even though you're debugging through that NIC. Because this debugging connection is going over the network, we require the specification of a 256-bit secret key so that we can encrypt and authenticate the packets. Other debug transports don't require this because they require physical access to the machine, but network debugging requires encryption and authentication. We support a number of different Ethernet NICs from several different vendors. Intel, Broadcom, and Realtek are shipping supported NICs, and we also have support for extending network debugging to NICs from other manufacturers. There are two different ways that you can set up network debugging. The simplest way is to use support that Visual Studio has for automatic target machine configuration. You can also set it up manually by using BCDEdit. Most developers who've done kernel debugging on Windows 7 already know and love BCDEdit. To turn on network debugging with BCDEdit, you simply specify that you want to do net debugging. You specify the host IP so that you're pointing the target machine at the host machine, and you specify the network port that you want to use for that particular target machine. It's very important that each target machine has a unique port assigned to it so that if you're debugging multiple target machines from a single host, each target machine has a unique connection to that host. When you run BCDEdit-DBG settings to turn on network debugging, it will spit out a key automatically if you don't specify one on the command line. This key is generated with cryptgenrandom and is a secure key that we encourage you to use. The nice thing about an automatically generated key is that it actually has 256 bits of entropy in it, and it's cryptographically strong. This is a much better key to use than a manually chosen key. The other thing that you need to do after you specify the network debugging settings is to actually turn on debugging. You do this by simply saying bcdedit-debug on. After this is done, on the host machine, if you're going to run the debugger directly from the command line, you simply type windybg-k. You specify that you want to use network debugging, and you tell it the port, and you paste the key that was generated on the target machine onto the command line so that the debugger knows what key to use. It's very important that when you transfer the key from the target machine to the host machine, that you don't move it in the clear over the network. This will completely defeat the purpose of having a key. A simple way to do this, instead of moving it over the network, is to cut and paste the key into a file that you save on a USB dongle. Now I'll show you a demo on network debugging, how you set it up and how it works and how fast it runs. Okay, so I'm going to show how we turn on debugging on the target machine. This is our Nike device, and I'm going to go to the desktop and run a command prompt. Elevated command prompt. And then I'm going to run bcdedit. First, I'll set up the debugger settings. And our target machine has a host IP of 169.254.60.175. And I'm going to use port 50,000. And as I talked about, it generates the key and spits it out on the screen. And then we'll turn on debugging. And we will set it up to restart. Okay, so our target machine is almost ready to go, and now I'm going to set up the host debugger, and then I'll reboot the target machine once the debugger is running. So to run the kernel debugger, you go to the debug menu and you say attach to process, and then you switch the transport at the top to kernel debug. Windows kernel mode debugger. And I have the Nike machine set up here. And if we go look at its settings just to see, we can click on Find, and we can click on the Nike. And it shows that it's set up for network debugging with the port of 50,000, and it has the same key. And so we say OK. And we click Attach. OK, and so now the host debugger is waiting to go. And so now I'm going to restart the target machine, and it will connect.
Again?
OK, so now we reboot the target machine. OK, and so now you see that the target machine has been connected to by the host, and the debugger is connected. And the target machine will boot up all the way, and then we'll break in the debugger and run a few commands. OK, so the target machine is up and running, and now we'll break into it, and now I will run some commands on the host machine. So let's just run bang CPU ID. And one of the things you'll notice is that we have IntelliSense in VS for debugger extension commands. So as you're typing it in, it will show you the list of commands that match what you've typed so far. And so this has got 4 procs. And if I dump the stack, it'll show us where we are in the stack. And bang PCI tree. It shows us the devices there, and we'll show the processes that are running. Okay, it dumps out all the processes that are actually running right now. And we have a kernel debugger running inside VS over network debugging. And that's how you can debug the Nike device that you have, is turn on network debugging using the dock and use VS, and it works great. The other transport that we've added to Windows 8 is USB 3 debugging. This support is shipping in the current builds that are released at the build conference, and it supports USB 3 XHCI debug compatible hardware. Intel, as part of its XHCI specification, added a spec for debugging to XHCI. USB 3 XHCI controllers with XHCI debug support debugging on any of their ports. This is a very nice feature compared to USB 2, because with USB 2 debugging, you had to actually plug into exactly the right port in order to make debugging work. With USB 3 debugging, it doesn't matter which of the USB 3 ports you plug into. All of them can be used for debugging. In addition, USB 3 debugging is much faster than USB 2 debugging. Even though USB 2 theoretically has a speed of about 40 megabytes a second, because of the way the debugging protocol was designed in the hardware layer, the maximum transfer rate that you could get on USB 2 is about 250 kbytes per second. With USB 3, this limitation is eliminated, and so USB 3 debugging is much, much faster than USB 2 debugging. Silicon vendors are already starting to produce parts that support XHCI debugging on their USB 3 controllers. And USB 3 XHCI debug should be available on most machines in 1 to 2 years. To set up USB 3 debugging, again, you can use VS to set up the target machine automatically, and you can also do it manually. To do it manually, you need to actually specify 3 command lines instead of the normal 2. The first is you specify the DBG settings. You specify that you want to do USB debugging, and you specify the target name for your test machine. This target name, again, must be unique for each of the target machines that you may have connected to a host. The next thing you need to do is you need to specify that you want to use the kdusb3.dll transport specifically. This is something that you will need to do on the current release for build, but is not something that we will have to do long-term when Windows 8 ships. To do this, you specify bcdedit-set dbg transport : kdusb3.dll. Actually, that's wrong. To do this, you specify bcdedit-set dbg transport space kdusb3.dll. The final thing that you need to do is turn on debugging by saying bcdedit-debug on. All of these commands must be run from an elevated command prompt. On the host machine, to fire up the debugger, you simply tell the debugger that you want to do USB debugging, and you specify the target name. Now I'll give you a demo of USB 3 debugging. I'll show you how to set it up on the target machine and on the host, and we'll see how it runs. So on the target machine, we're going to run an elevated command prompt, and we'll run bcdedit. And we tell it we want to do USB 3 debugging, USB debugging, and we tell it the target name. And the target name we're just going to say is USB 3. Okay. And then we're going to run a special command that forces it to use a particular transport DLL, which is kdusb3.dll. So we say dbg-set dbg transport, and we say kdusb3.dll. That forces it to use the kdusb3 DLL. This will not be required when Windows 8 ships, but it is required for the build release. And then we turn on debugging by saying bcdedit-debug on, and then we set it up to restart it. Okay, and so now the target machine is ready to go. So again, we go to run the kernel debugger. You go to debug menu and you go to attach to process, and we select kernel debugging, Windows kernel mode debugger, and in this case the machine is this one, JBL 3 USB 3. And if we go look at the settings for it, we can see that the connection type says USB and the target name is USB 3, and that's good. And the actual cable is right here, and it's an A to A USB 3 cable, and it's going to, in this instance, a Renesas USB 3 card that has the debug support. So now we'll fire up the debugger. And the debugger is ready to go, and so now we will restart the target machine. Okay, so now we are going to reboot the target machine and wait for it to connect to the host. And this is a normal desktop machine because right now the only hardware that we have for USB 3 is in an add-in PCI Express card. Okay, and we see that the debugger connected, and we'll let the machine boot up all the way, and then we'll run a few debugger commands. Okay, the machine is up. We'll break in, and we'll get a stack. Now I'm going to run a few commands. I'll run bang CPU ID, and you can see the IntelliSense running, and it shows us the processor, and we can run bang process 00, and it'll dump out all the active processes, and you can see that it's pretty fast. And we can do bang PCI 3, and it dumps out all the devices, and we'll dump the stack, and there's the stack. And so you can see that USB 3 debugging works great. We hope that you'll use it and make sure that you get hardware that supports the debug registers. We want to encourage all of you to support USB 3 and network kernel debugging in your new Windows systems. We believe that USB 3 and network kernel debugging will be viable for at least the next decade, and they will be very fast and reliable transports to use for debugging Windows. I'll now turn the time over to Tanya, who will talk about the Windows 8 debug certification requirements that we have.
Hardware development cycle starts from technology or standard to developing the first prototypes and components to manufacturing a real device. Engineers then create a firmware and software for that device and incorporate the device driver in Windows. This is a really time-consuming and costly process, and hardware or software errors may cause designer iterations, delays, and additional expenses to ensure the ecosystem can actually find and fix the defects. The overall goal of the device program is to deliver hardware device support with minimum bill of materials costs and minimum support costs. The chief sources of hardware design expense are gate cost and marginal value innovation. The chief sources of software design expense are device driver lifecycle cost and customer support. The worse the hardware and software quality issues are, the larger the device category grows. Existing OEMs that have found system errors with their machines and failed to provision kernel debugging cannot get support from Microsoft, ODMs, IHVs, chip vendors, cell designers, and any ISVs that use their system resources. In fact, any machine that cannot be debugged is essentially a market failure and is a doomed OEM design. That's why our goal is to make all Windows systems debuggable, which is each OEM machine must include an available debug port. We can maximize the value by reusing the existing ports for debugging and leverage hardware for customer benefit. In fact, every type of debugging hardware we've built to date is also usable for some other type of end-user scenarios when debugging is off. This is true for serial, 3094, USB 2, Ethernet, and USB 3 XHCI debug. The Windows system is not kernel debuggable if it doesn't really have a usable debug port. For example, if a cost-reduced machine has a scenario that uses the debug port for the customer scenario, then that scenario is indebuggable. If the scenario is indebuggable, that machine is also indebuggable, and this becomes a design failure. Good example is using the only USB 2 OTG port for any of the following: IP networking, mass storage, keyboard, mouse, charging, or docking. But this exact same situation can occur with any type of debug port. It's not particular to USB 2 OTG. One solution for providing more debug ports, especially for the small form factors, is to use the dock for adding more user-accessible ports. In the case of the Nike device, we've added an Ethernet adapter, in this instance 1 gigabit Realtek, and RJ45 port on the back of the dock. Additional possibilities include using the communications hardware for debug connectivity purposes. For example, you may want to consider wiring the UART to the external audio port or to the unused pins of the HDMI port. The solution is up to you, and it will work as long as you provide a cable and ensure that kernel debugging actually works. Since Microsoft develops both debugging and protocol stacks for the same hardware, another problem comes into play: the fragmented nature of the hardware market today, especially the SoC market. We will be having new partners and non-compliant silicon for at least a few more years. We cannot provide a debug transport for each specific hardware implementation. That's why we recommend the following long-term solution: use standard debugger transports and existing supported chipsets whenever possible. This will allow faster bring-up process, low support cost, and the overall health of the ecosystem. To achieve this goal, for Windows 8, Microsoft introduces hardware requirements for debugging and Windows certification kit tests for debug capability. The goal of the hardware debug requirements is to ensure all Windows systems are debuggable in all scenarios. Any two types of ports are allowed provided they each can be used for debugging and for normal customer scenarios. For example, Gigabit Ethernet and a USB 2 OTG device, or USB 3 XHCI and serial UART, or 3094 and USB 2 EXCI host debug. If the system has USB 3 controller, it must implement USB XHCI debug and expose USB 3 ports capable of debugging. You can find the hardware debug requirements under the System Fundamentals category. They are valid for all x86, MD64, and SoC systems. These are the Windows hardware requirements for debugging in preferred order based on available hardware and speed. We require that systems provide support for at least two of these for debugging, preferably Gigabit Ethernet and USB 3 XHCI debug. We also ensure that Windows 8 ships with in-box support for all of the recommended debug hardware. Currently, we support the standard USB 3 XHCI debug capability, about 200 Gigabit Ethernet adapters from Intel, Broadcom, and Realtek, USB 2 OTG implementations based on Chip Idea, NVIDIA, and Mentor graphics, the standard 3094 and USB 2 host debugging, and serial 16550 compatible UART. To emphasize on the key points once again, use standard debug transports and existing supported chipsets whenever possible. Support USB 3 and network kernel debugging in your new Windows systems. Provide more than one port for debugging. Now, when you know why you want to make your system debuggable, I would like to talk about how you can validate them through the Windows certification program. The Windows certification process ensures all Windows systems meet the requirements and pass certification tests for debugging. There will be some exceptions for the existing Windows 8 hardware that cannot comply with the debug requirements. The exceptions are granted for a very limited duration and are conditional on the OEM IGVs agreeing to update their implementation within a reasonable amount of time to meet the Windows 8 requirements. We enforce Windows 8 hardware debug requirements by introducing two new debug capability tests in the Windows Hardware Certification Kit. Windows Hardware Certification Kit is a client-based server studio that ensures the right tests are being run for your system and a submission packet is generated ready to send to Microsoft. Windows Debug Capability Test under System category runs on every Windows architecture and ensures your system supports debugging on two of the user-accessible ports. USB 3 XHCI Debug Capability Test runs on systems with XHCI controllers and ensures that the system implements XHCI debug support and exposes USB 3 user-accessible ports for debugging. During Windows 8 development cycle, we are happy to work with many partners to raise the ecosystem awareness about the new hardware debug requirements and Windows certification tests for debugging. Make use of the new hardware debug requirements and be great on delivering your high-quality Windows 8 systems. Check out our information and links on the new debug transport and certification program. Also, make sure you see the following related presentations on designing great Windows 8 systems. Thank you.